called row transformations. And as your calculator is doing RREF, it's doing a sequence of these three rows transformations in whatever order it needs to do to make it work. Okay? The first thing that I may do to any row is I may multiply it by a non-zero scalar. Just a number. I can multiply any row I want by 3 if I want. I can multiply any row by -3/4 if I want. Okay? And the reason I can do that is it's a lot like thinking of multiplying two sides of one equation by the same number. As long as I multiply one side by some number, I can multiply the other side by the same number, and it's all legal. Okay? The next thing that I can do is I can interchange any two rows. Okay? If I want to write the third row first, I can switch the first and the third rows. If I want to go 3, 2, 1 or 1, 3, 2 or whatever, I can swap any two rows and it's an equivalent matrix. Okay? It's just like having a system of equations. It doesn't really matter which equation you write first, which one you write second or third. It's all the same system, right? Okay? And the third one is the one that we use most of the time. It's like the one that really feels like something tricky arithmetic is happening. Okay? Is I may substitute, how do you say this? You can substitute one row for the sum of that row and a scalar multiple of another row. Okay. So I can replace like the third row with 2 times the second row plus the third row. If I multiply the second row by 2 and add that to the third row, I can make up my new third row. Okay?
Say that again? If you multiply the second row by 2, add it to the third, that'll make it 4?
No, that can make you a new third row.
A new third row?
Yeah, I can replace one row with the sum of that row and something else added to it.
Is that only the third row you can replace?
Or any of them.
To any of them?
Any of them, yeah. Okay? Yes. Yeah. Now, you need a sort of intuitive approach to some of these examples. I mean, if you're working these guys out by hand. And I'm not even going to do anything hard. I'm going to do a simple one. I'm going to do 4x minus 3y equals 11, 5x plus 6y equals 4. I'm going to solve this guy using these row transformations and everything by hand. Okay? So the augmented matrix is a 2 by 3, right? What I'm hoping to have happen by the end of this is I want this to look like 1, 0, 0, 1 with some numbers over here. So that those numbers can tell me what my solution is, right? So the trick is to get zeros and ones. And you'll notice I don't have any zeros or ones. So I got to do whatever I can to come up with a 0 or a 1. Actually, I really want a 1. I'll take care of the zeros once I get the ones. Okay? So what I see is if I do 5 minus 4, that'll get me 1. Okay? So I'm going to replace row 2 with row 2 minus row 1. So row 1 remains unchanged. Row 1 stays 4, negative 3, and 11. And then 5 minus 4 is 1. 3 minus a negative 6 is really, no, sorry, 6 minus a negative 3 is really 3, 6 plus 3, so 9. And 4 minus 11 is negative 7. Okay? Now, next up,
Would that be the interchange?
No, that's this one right here. Yeah. I substituted this row with this row plus -1 times this row, really. Okay? Now this gives me a 1, but the 1's in the wrong place. In the first column, I want the 1 up there. So I'm going to switch row 1 and row 2. So I'm going to do 1, 9, -7, and 4, -3, 11.
Why did you just subtract row 2 from row 1? I thought you had to...
I didn't. I subtracted row 1 from row 2.
Huh?
You said it backwards.
Oh, you subtracted then...
I subtracted this row from this row. Or what I really did is I took this row and I added it to -1 times this row. And then actually I did a substitution there. Okay? So now that I've got the 1 right there where I want it, I can use that 1 to get a 0 right there. To get a 0, if I multiply 1 times -4, -4 plus 4 would get me 0, right? So I'm going to do row 2 minus 4 times row 1. Now row 1 stays the same. It stays 1, 9, -7. And then -4 times 1 is -4 plus 4 is 0. 9 times -4 is -36. And -36 plus 3 is -39. And then, oh crap. Yeah, it's 28. Plus 11 is 39. Mm-hmm.
Oh, I see. So you're multiplying the top row by 4. Or -4.
Yeah. Yeah. And then adding it onto... Alright, so I got half the matrix I want. I've got the 1 and I've got the 0. So then, the next easiest thing to do is to get a 1 right there. Now, to get a 1, I just have to multiply this by -1 over 39. I basically go through and I divide everything by -39 to get a 1. Okay? So I'm going to do -1 over 39 times row 2. So row 1 is still 1 and 9, -7. And this is now 0, because 0 divided by anything is still 0, right? And -39 divided by -39 is 1. Positive 39 divided by -39 is -1. And I got one more step. The last thing that I need to get it to look like this is to get that 0. I've got the 1 here, the 0 here, and the 1 here, right? So I'm going to multiply this bottom row by -9. And I'm going to add it to this one. So I'm going to do row 1 plus -9 times row 2. And notice when I take the bottom row 0 and I multiply it by -9, it's still 0, right? And then adding 0 to anything doesn't change it, so I don't lose my 1. That's the critical thing. So that's 1, 0, -1. And let's see, I know that's 0. That's why I picked it. But when I take -1 times -9, -1 times -9 is positive 63. No, fuck. No. Yeah, it's just 9, isn't it? -9 times -1 is positive 9. And positive 9 minus 7 is 2. And there it is.
It's not really hard, just tedious.
That was my solution. Tedious, that's a perfect word. Guess how many places there are to make a mistake? About 157 on this problem. Imagine having 4 equations and 5 columns. It's ridiculous to do by hand, okay? And this was a simple 2 by 3, right? God bless the RREF, right?